the world's most technically proficient of teachers. Right, I make that 6 p.m. on the dot. So welcome all. Thank you very much indeed for coming along. Can I just say that obviously we're on the cusp of the May session, and if people have still have things outstanding, then I wouldn't worry. We've still got a number of days to the deadline. We are where I work, we're a November school, and I'm sure that a couple of my kids are on there, so thank you for any current AIS kids which are on and watching this live stream in the middle of your holiday. And shout out to Dawn, who's there in America at 6 a.m. Okay. Thank you all for subscribing, and thank you all for joining this evening. So welcome to the show. I'm going to go through 10 things which hopefully you find useful, helpful, perhaps can add a couple more points to an IA. So hopefully some easy remedies that you can do. I know that some schools are IA only. I know that every mark really does count on the IA, as we all know, and can make a difference. It can actually make a great difference, just 1 mark on the IA, given it's 20% of the overall IB score. Okay, let's get started. So, coming in at number 10, we have make the pages count. Okay, so we don't want to see, there's no point putting in title pages, they count. No point putting in indexes, it's only 12 pages long. We know what the headings are, or what they should be throughout the internal assessment. Appendices, we don't need to read them if they're after the 12-page limit. And any excess or unnecessary images have been mentioned in the exam reports, the examiner's guides, for the last 3, so November 20, May 20, and November 19, all mentioned. Excess images are not welcome and will not gain any marks. They're just seen as filler in the IA. I think this is a great little discussion. I know that if you've been onto my IB, you will see that science is the only group where they just give a page limit rather than a word limit. So if we think about the extended essay, it's 4,000 words clearly, and talk is 12 or 1,600, I forget. But chemistry IA and physics and bio is just 12 pages. And 12 pages can be used in many different ways, as you'll see on the next slide. And as a moderator looking at the pages, how the student has arranged things, has used the space available to their best advantage, can literally triple the amount of words that they've put in there, and clearly show a greater degree of personal engagement, exploration, and much more space to evaluate what they have done. Okay, so make the pages count, don't count the pages, and don't go beyond 12. The IB did say that if you go to 12.5 pages, then they're going to still mark it. They're not going to be that pedantic, and they said that in the last examiner's report. But seriously, just keep it within 12, and excess, just filler, is seen just as that and will detract from any personal engagement marks which you could potentially have got. Okay. Please feel free to type in any questions as I am chatting, freestyling through these slides. So here's what I'm talking about. This is use of the page. So on the left-hand side is a standard IA. I'm looking, it looks like salicylic acid, iron 3 chloride test, goes purple, rate of hydrolysis of aspirin. It looks like that sort of practical. Okay, that's one side of A4 in that internal assessment. And then on the right-hand side, we have a different use of the page. And I can clearly see, even just, first impressions counts. Don't forget that moderators we are human beings, unfortunately, and we are subject to bias, and first impressions do count. Okay, we try to remove bias as much as possible, don't get me wrong. But you look at these two pieces of paper, the one on the left says to me, okay, the students made an effort, they've tried their best, they've put their heart and soul, hopefully, into researching, although there are no references. They've tried their best with nomenclature. It's all SI units. I can immediately see, however, the H2O, the 2 is not subscript, so they didn't care that much to do that much. I can see at the bottom, which is highlighted in orange, they've used milliliters. SI should be centimeters cubed. They've said it's 16 grams of pure ethanol inside, when it's 20 mils of 98%. Just on first reading, I'd need to do the calculation. That doesn't seem to make much sense. The iron 3 chloride on the bottom left is 0.41 from a molarity of 0.5 mol. It just needs a lot more explanation. I'm not doubting what the student has done in terms of having veracity or correctness or authenticity, but there's a lot of questions in there. The hydrochloric acid doesn't have concentration, for instance. There's a complete absence of any uncertainty throughout, and the level of the actual chemistry of the approach is, I'm sure you would agree, pretty much on the basic side. Okay. Look at the one on the right hand side. I can see immediately we've got some crystal violet. I assume it's sodium hydroxide crystal violet. It is. I can see chemical equations. I've not even looked at what they are yet. I can see a reference to Jim Clark of Chem Guide and Chem Libre texts, which we all love. I can see that the student has used some differentiation to get the first order rate equation. Immediately, I'm impressed. Because why? Because there's chemistry. It seems correct on first glance. I would need to dig even further. There are references. There seems to be a clear extension of the syllabus. And don't get me wrong, you don't need to. The student doesn't need to go way beyond the syllabus. That's not the point. They are 17, 18-year-old kids. We totally get that. But we would expect a level of chemistry at International Baccalaureate Chemistry level. Is the one on the left-hand side IB level? Potentially. Yes, potentially. Is the one on the right IB level chemistry? Most definitely. There is no question, no room for manoeuvre. That is definitely IB level chemistry. So use of the page. I've not counted the number of words on the left-hand side versus the number of words on the right-hand side. Perhaps I ought to have done that, but clearly I'd hazard a guess at double the amount of words and certainly more than double the amount of chemistry on the right-hand side than there is on the left-hand side. Okay. Is my volume okay? I seem to be just talking into the ether. Yeah, volume okay? Okay, I can hear myself now. That's great. So, use of the page. Next one, as I mentioned, we will be looking at raw data tables. So, two different raw data tables. One on the left looks like thiosulfate. It could have been a disappearing cross experiment. And the one on the right. Okay, again, first impressions. What about the one on the left? Well, the independent variable is in the left-hand column. That's great. The uncertainty has 2 decimal places, and the data has 2 decimal places. That's lovely. The dependent variable is the volume in cm cubed of sodium thiosulfate. It gives the concentration of the thiosulfate, and it gives an uncertainty with consistent decimal places with the data in the table. There's nothing I can really fault about that. It looks pretty good. It looks pretty consistent. I can see a trend as the temperature has gone up. The average amount of thiosulfate has gone down. So that's smartly presented. That's pretty good. So what's the difference with the one on the right-hand side? Well, this is one that is a little bit more, needs a bit more nuance to perhaps pick up, because the table on the left-hand side has merely given the total volumes. And again, this has been picked up in examiners' reports as an issue in the last 2 examiners' reports, that students for raw data need to put the beginning, the initial reading, and the final reading, and then give the total volume which was used, so subtracting B from A, or the final from the initial, whichever way you want to do it. So the left-hand side would actually be marked down, because that is not the raw data. That's the total volume. Yes, they've calculated an average, they've processed, but that is an error which does catch out many students, and they would lose a mark at least. Probably just 1 mark on the left-hand side, because the uncertainties, decimal places are good. I like the presentation actually. They've just not done the initial and final. And this is the IB as we know and love it. There is guidance in the syllabus, and there's the examiner's report, and they must be both read in tandem to give the students the best chance at success in their internal assessments. So the volume of iodine in the table on the right-hand side, I've got the initial, the final, the total. I do have a small issue that there are inconsistent decimal places. If you look at day 1, 3.5 on an uncertainty of 0.05, it's not an immediate mark down, but it's something to bear in mind if the student continues to be making more errors of that ilk. then that would potentially be a mark down. But just 1 or 2, that will go through. That's absolutely fine. Okay. We're looking over here at trial 3. The total volume only has 1 decimal place, but we have 2 decimal places throughout here, and it's 1 decimal place there. So I'm on the edge of deducting a mark on the right-hand side, but certainly the right-hand side table would be, so if I was giving it a band, it'd be 5, definite 5 out of 6. The one on the left-hand side, because there's no initial, no final, that's going to be 3/4 out of 6. Okay, so it's just knowing, and I know that it seems like there are these invisible hoops which the IB wants us to jump through, and I guess it's our duty to read the examiner's report and see where they are. Okay, so the raw data table, make sure you've got the initial and final, not just the difference. Now those pesky variables coming in at number 7. Again, I should have had a drum to drum roll these in. Coming in at number 7, those pesky variables. First impressions of these 2 different IAs, which I've just screenshot their variable treatments from. Hi Anupa, welcome to the live stream. On the left hand side, it's the use of the page again, which was number 10, is way less effective than the student on the right hand side. The control variables, the student on the left has 1 control variable. It looks like an enthalpy of combustion of the alcohol's internal assessments. They have done the 3 columns. What's the control variable? Why is it being controlled, and how to control it? And we'll have a look on the right hand side what they're doing in a second. Independent variable is correctly identified. Is it? No, it's not, is it? The independent variable says the amount of carbon in the alcohol. I suspect it means the length of the carbon chain. It does. That's what they mean, because they say that in the how to change it. But that's a basic. And then the dependent variable, different amounts of alcohol are consumed. That is not a dependent variable. And every year it comes up with regards to the dependent variables. The student will put the dependent variable is enthalpy of combustion, the dependent variable is Kc, the dependent variable is rate of reaction, etc. Okay, the dependent variable is none of those things. The dependent variable, as we all know, is what the student has actually measured. Was it temperature? Was it volume in centimeters cubed? Was it absorbance on a colorimeter, for instance? So the raw data, whichever gave you the raw data, that's the dependent variable, not the thing that's being calculated from it. So that's the left-hand side. That's a very, dare I say, basic treatment. On the right-hand side, we have independent variable, temperature, we get the range, and we get the uncertainty. So what are the different values we're going to be using, and what's the uncertainty on that value? The 0.5 on the 1 decimal place. That's very good. We're very happy. Dependent is absorbance. It is. I guess you're going to get concentration from that once you've done your A equals ECL plot. And then control variables. I always encourage my students to do a table for these, because it just works every time. I've got 1, 2, 3, 4, 5. I've got 6 control variables. Brilliant. How are we going to control it? Use the dilutes only in order to perform the isolation method, find the order. Use this concentration. Use this volumes, consistent decimal places with the uncertainty. I'm a complete, almost religious about these things. Wherever there's a number, there should be an uncertainty throughout. So don't give the moderator any room for manoeuvre on marking your internal assessment only to a beautiful standard. How is it controlled? And then the possible effects. So the students put, whilst changing the concentration of this reactant will not have a huge impact on the rate of reaction, as it's in large excess, it is still essential to keep its concentration constant to keep the results valid. Within the control variables, another thing which is often lacking is something that proves that the student is studying what the research question is saying they are going to be studying. If you're studying the effect of temperature or concentration on rate, and you're looking at one of the reactants on rate, you have to make sure that that reactant is limiting and prove that it's limiting, and everything else is in excess, or you've not controlled the variables. That's a standard thing which students get wrong. So IV, range, uncertainty, DV, what you actually measured, and 6 control variables with how you're going to control it, and what would be the effect on the outcome of the investigation if they were not controlled. Then we're looking at the top bands. for these pesky variables. On the left hand side, that's probably going to be 1 or 2 out of 6. Probably 1 out of 6 because the DV is not intelligible to an intelligent reader. The IV is difficult to understand, and the CV are very limited, very basic. 1/2 on a good day. The one on the right hand side, that's probably, if they've done the limiting reactant calculation, which I assume was beneath it, I didn't copy that bit, I'm sure it was, that's probably a 6 out of 6 on the variable treatment for that aspect. Okay, the importance of a trial. This comes from the examiner's reports as well. So every student who does an IA, we assume they've done a trial to work out the parameters of the experiments. Was the temperature range effective to test the research question between 10 and 30 or 10 and 50 or 40 and 100 degrees C? Where is the data for that trial? Include the trial results. Why include the trial results? Because immediately you said you've done a trial, these were the results, this is how I chose the range of my independent variable, or this is how I chose my dependent variable because it gave me the most authentic results to test the research question. This is all gold for personal engagement and for exploration. Because your moderator is going to be checking and looking at your method to see if it tests the research question. Standard fall downs are, as I've already said, the limiting reactant excess reagents to prove that you are studying the reactants that you are studying, because if not, then your method is flawed and doesn't test the research question. Or if you're looking at the average rate and you plot instant rate or vice versa, that's another common flaw in the research question. If the research question is vague and doesn't say whether it's initial or average rate, and you do the other one, you're in trouble with regards to the validity of your method to test your research question. And this is the IB, as we know and love them. We are expecting reflection throughout on how effective your established method is as a valid test of your research question. So at every stage, maybe the students added 10 cm cubed at 5 degrees C and stood there waiting for 3 hours and nothing happened. Record that, say that, and then say, okay, we're going to start it at 30 degrees C. And then it only happened in, 2 minutes. Okay, we've got a starting point. But you've reflected, you've changed course, you've come up with a solution. This is beautiful personal engagement and exploration, which will then flow through the whole report. When we're looking at communication, how well did you communicate what the trial showed you and how you responded to the results of the trial? There's no shame in changing direction during the internal assessment. There's only shame in not recording the facts that you changed course and denying yourself of some wonderful marks at the top bands of exploration. Tables. Those tables. So I encourage my students, all students, regardless of who teaches them, will have a raw data table, a process data table. I also encourage tables throughout for control variable data. A big one which is often missing is a student will be looking at the effect of temperature on rate. It's a very popular internal assessment, but they will give no hint or evidence about how they controlled the temperature. Okay, so as we all know, 90% of reactions are exothermic. They're going to generate their own heat. When you mix two different liquids together or add a solid to a liquid, whatever it happens to be, the temperature will change. But the student needs to have monitored that, to have recognized that. And there's all too often an assumption that a water bath set at 20 degrees C, or they may even say, and be cute about this, 20.0 degrees C plus or minus 0.1 degrees C, which is great treatment of number, but it is just a water bath which cost a few $100 US and is roughly 20 degrees C. It's not an accurate, that button on the front is often assumed as an accurate measure. The other thing they do is they put thermometers into the actual water of the water bath rather than into the solution that they are testing or that they are recording, volume of gas or colour change or whatever it happens to be. And you need to have a thermometer probe in there and recognise that that is a systematic error throughout your experiment. It's not enough to assume that the water bath is this magical piece of kit which is going to control the temperature. So record the control variable data and a controlled variable data table. Okay, I used Excel to find L and K, good, which did not round values. Yep, however my data table has rounded values. When finding L and K, I used the values for Excel, but forgot to mention it. Would I be penalised heavily? No, I think, I'm assuming your moderator will pick that up as an honest mistake. You'll probably just lose 1 mark, I guess, on that swap Nasha. Apologies for my pronunciation. Okay. Process data. Don't forget the raw data is the raw data. It's not the total volume, it's the initial and the final. Control variable data. Prove that you've controlled the variables you said you're going to control. If you're going to control temperature, go for it. If you're going to control humidity, be realistic. That's an uncontrolled variable, not a controlled variable. I don't think anybody has a magic wand to control the humidity, or indeed the pressure. Again, the mythical, magical powers seem to be invested in an AC unit controller to control the temperature by too many students, and it really is not the case. Process data, what can we see on the right-hand side? I've got a tertiary bromoalkane and sodium hydroxide. We're looking at the rate of SM1 reactions, 2-bromo, 2-methylpropane, sodium hydroxide at 40 degrees C. Table looks good. They could have put their uncertainty next to 40 degrees C, bit lazy. I'm nitpicking. But the uncertainty is here for the concentration, here for the sodium hydroxide. We've got the trials in time. Time is 0.5 seconds. I would accept as a moderator anything between 0.5 and 1 second for time. We still see 0.01 second uncertainty on a stopwatch, which is the precision of the stopwatch, but it's not the precision of the human being operating it. Sometimes students will go onto a website and find their reaction time and take the average over 3. That's fantastic. Love it. Absolutely love it. My students are guide plus or minus 1 second. That's average human reaction time. So this data table looks good. It's got the uncertainty calculations underneath. It's got any mole calculations set out underneath. All dilutions are worked out step by step so the moderator can go through. I'll have my calculator just checking all these things, and you can pretty much see where they are going. Are their decimal places consistent? Is their treatment of number robust? On the right hand side, yes indeed. Okay, now the treatment of significant figures, decimal places, uncertainties, I'm not going to go into any depth in this video, but I do have, as you can see, chemistry, a previous live stream where I did in-depth uncertainty treatments from very basics, burettes, thermometers, pipettes, through to more advanced things where you're taking natural logs, Arrhenius equations. How do you do uncertainties on those? So have a look at that, but that's not the subject of today's lecture. So, Anupa, how to control temperature in exo-endothermic reactions? Anupa, great question. The answer is you can't. Okay, you could you could try your best to swathe it in ice or surround it by hot water. You just have to. What you have to do is to show the awareness in your IA that indeed heat has been generated or endothermic and the temperature's gone down. You've monitored that temperature change. If you're doing 20, 40, 60, 80 degrees C, you'll make sure both solutions, or you're starting at 20 degrees C, but you have to be honest. The person marking your work is a chemist. They probably know it's going to go up. It's probably going to go up. They know it's going to change, but you need to monitor it. As long as the starting point is the starting point that you've said in your independent variables, that's as much as you can do. But the thing that digs a student into a hole is when they assume that it stays at that 20 or 40 or 60 degrees C and doesn't change as the reaction proceeds, which is clearly incorrect. So Anupa, I hope that answers that question. I'm just looking at the iPad, sorry. And Dawn, would you suggest showing all those calculations, or would a sample plus of the trials calculated similarly be sufficient? It's enough to put in one exemplar. So there are 3 results here, and they've used one exemplar for the sodium hydroxide, and then the dilutions which will apply to the rest of them. So as long as each calculated value in your internal assessment has one exemplar, if it applies to the full table, just say this applies to the full table. As an example, line 1, this is the results for line 1, these are the results of the calculations. That's absolutely fine. Yeah. Okay, I hope that answers that question. Please keep typing away. I'll keep looking as I'm talking. Just uncertainties as soon as my clock strikes 6. No, that's a previous one. And coming in at number 4, the pesky evaluation. Now, there are many ways that a student can generate an evaluation. Sometimes I see an evaluation and it's 3 pages of essay, and first of all it takes a long time to delve into it, which we do. Every word is read. Every word is read. We go through that. However, again, what I motivate my students to do is use another table. Okay, what's in the table? Well, what's in the table is what's come from the rubric, which is here. So I asked today on my IB if I could share this. This is guidance for DP Chemistry IA for from March 21, just last month, by Elisa Jimenez Grant. I'm so sorry if that's not pronounced correctly again. I have previously used her work. I think I got it from my IB, and I'm very grateful for her for allowing us to use it today. I will share this underneath the video. She's used a number of teachers across her network, and also Brown and Ford and Jeff News, as I'm sure we all know. And this has everything that we need for, as well as the grade descriptors. It gives specific guidance for each of the criteria. It's probably a little bit late now for May 21, but it's certainly of value, and it made me feel a lot better knowing that I've been moderating for about 7 years now. Elisa has been moderating for 11, so she wins. Okay, and she's saying, answer your research question, describe trends, refer to your observations, explain the trends using science, describe and explain the answer to your research question. What difficulties did you overcome? Again, this is the reflection thing I was mentioning earlier. Don't say prove. I'd probably avoid fair test as well. That seems still a bit GCSE. If you can, wherever you can, compare with the literature, there must be a calculation of percentage error, and you must assess systematic and random errors. Now, I have had a little bit of flack, I would say, from previously saying you've got to have systematic and random errors. So it's great to see it there. Where else do you see this? You see this in the examiner's reports. You'll also see it on the teacher support material on IB. So if students have not put systematic and random error analysis into their evaluation, they're never going to get more than 3, maybe 4 at best, more likely 2 or 3 on evaluation. And evaluation is notoriously the most difficult thing to achieve on. Students get tired, they get bored. It's like, oh my gosh, I've got to do this now, really? Okay, so I'm not going to read this through, but Elisa has suggested that you could do a table. We love our tables in chemistry. What was the limitation or weakness? I would put that as systematic or random errors. What was the effect? And what's your suggestion for improvement? How are you going to improve it? Because your moderator's looking at the rubric going, did they identify it? What's it going to do? And what they're going to improve? And now I can just go tick, tick, tick. So when I look at this student here, they've done what's the equipment? What's the uncertainty? Smallest quantity measured. That's their own invention. They were not asked to do that. Percentage uncertainty, possible effects on data, and suggested improvements. Okay, just while we're here, suggested improvements is not more. It's not more of the same. Do more measurements. It's looking at some more sophisticated instrumentation. It's looking at improvements to the method. It's looking at perhaps changing the research question. It's going back to that idea of reflection again, reflection throughout the IA to hit the high bands. The evaluation is over 2 pages. Not a big deal, because I know the student was gunning for 12 pages. And not only do we have a discussion of the results, which refers back to the research question, they've got an exponential regression function. Did it answer the research question? What's the type of correlation? Students do need to be able to have a reasonable level of mathematics to get the higher levels in chemistry IA. I've just done the training for this year's moderation, to be a moderator and team leader this year, and they listed all of the mathematics that students need to know. if you want to know what that level of mathematics is, I will share it under the video after this. So type into the chat if you want to see that. Okay, discussing the uncertainties, R-squared values, comparison with literature, what possible problems did they have, what did they overcome with these problems, what's the theory, is the theory correct, don't put bad chemistry in the IA, that's another thing. Overall comments, and then the evaluation. It looks at the equipment errors, which are here, experimental errors, limited IV, they could have extended it, that's great, that's reflecting on the method. And reflections on the method are where the high 5s and 6s come for evaluation. They mentioned the uncontrolled variables, and we also have, there's the comparison with scientific literature, percentage difference, about 18% difference, that's pretty darn good, And as you can see, the student has gone to the nth degree and probably gone beyond, even beyond the 6 possible marks out of 6 to ensure that they have hit the top bands. And look at that, beautiful personal engagement. Anyway, let's go back to the presentation. So, evaluation makes many people quite ill, but really, use a table, quantify it, refer back to your research question, do your systematic and your random errors. There's no reason why I shouldn't be getting 4 or 5, maybe even 6 out of 6 on evaluation. Graphs. There are a number of things to look for on graphs. First of all, labels on the x and y axis, tick, tick. Uncertainty on the x and y axis, tick, tick. A line of best fit. The line of best fit can be a curve of best fit, it can be a quadratic equation, it can be a parabolic fit, it could just be a y equals mx plus c. Say what it is. We want to see an r-squared value. They're looked on very positively. You don't have to, but they're looked on positively. And the other thing where you don't have to, but is looked on positively, are maximum and minimum error bars. Why are maximum and minimum error bars so powerful? Well, if with your error bars, your minimum and your maximum, here's the maximum, the orange one, goes through all of the error bars, that means you quantified correctly all of your random errors. But if it doesn't go through all of the error bars, like this one here misses this one, so you can talk about this one at temperature, is that 348, something around there, 348 Kelvin. Talk about this one, clearly has more systematic error in than random error, because all we can quantify is random error. Again, I have a video on this, but this is analysis and evaluation. This is where the gold is for analysis and evaluation. Even if you've got the uncertainties in the x and y axes, if you've just got the error bars, don't worry too much about the maximum minimum gradients. You're still going to be on around 4 out of 6. If you discussed it well and you put it into scientific context, that could be 5 out of 6. Okay, and to be clear, you don't have to do maximum minimum gradient. And clearly, if you don't know what you're doing with them, don't do it. Okay, you're just going to get no points and probably lose points on communication. 2, personal engagement. Personal engagement is not a section in your IA. It is not a heading. You can have a heading for analysis, evaluation, introduction, that sort of thing. It's only 12 pages long. But personal engagement is exemplified throughout. Again, it's been mentioned in previous exams reports. Don't put, since I was a small person, I've always been fascinated by the effect of temperature on KC. You haven't. It should feel like 10 hours. It should feel like 10 hours. I'd say at least one side of A4 at the end, within the 12 pages, should be extensive and authentic bibliography. You can look at known relationships. Known relationships are fine. There's no issue with looking at known relationships, but they should be extended and made personal to the student. The one that we saw a few years ago was kimchi and the amount of vitamin C in there. That's a nice one. And one that came up last year, which was mentioned in the examiner's report, was the effect of fructose on the inhibition of oxidation of vitamin C in a fruit sample. That was like, wow, why has no one ever thought of that before? I wish I thought of that. Make sure the chemistry is correct all the way through. Don't say that increasing temperature decreased rate of reaction when clearly it didn't. Have reflections throughout and how you responded to the challenges, responded to the surprises throughout the internal assessment. Excuse me. Okay, and make sure the chemistry is clearly IB level. Yes, you can argue that a basic mole calc is IB level. It is also a GCSE level. Make sure there's a demarcation. Make sure the chemistry is of sufficient difficulty to warrant it being as part of 20% of your IB. And rule number one, put my head of year hat on now, is be kind to yourself, really. You know, it is a process. It's a process started by you with your teacher. You had a research question, you developed it, you developed a method. It hopefully worked. We are all human beings, you're a human being, we are human beings, we're all doing our best. We want you to be at the top of the game, we want you to be all level 7. Help us to do that. Remember that we are perfectly imperfect, we are human beings, wabi sabi. And 90% of your IA is within your control, maybe even less. And the rest of it is up to the universe, I'm afraid. Maybe I should stop reading so much philosophy. But, you know, I got moderated down. Call me a senior moderator now because I'm a team leader. I was moderated down from an IA which I thought was 24 points down to 19 points last year. I was just flabbergasted. On appeal, it went up to 21 points, but that's beside the point. We are all, as part of the process, we all do want the best. And the best advice is set things out in tables, be very clear about what you are doing, reflect throughout, and don't give your moderator any chance to mark you down by making some of the errors which I've mentioned during this presentation. Okay, Q&A, over to you. Do you have any questions, guys? Could you also please share the document you showed before on the IA guidance? Yes, I do have permission from Elisa to share that, and I will append that under. I only got permission just before the live stream, so I wasn't able to do it before, but I'll certainly do it before I post it to my channel. So yes, that's fine, Sneha. So let's give it a few minutes, wait for any questions. I hope you all found that useful. There's nothing too scary in there, and hopefully some people can hopefully get a couple more marks out of the IA for the May or the November sitting. The presentation is shared under the video. Any documentation used within it I will share underneath the video as well. Again, I'll hang around, but just to say best of luck to you all, and thank you very much indeed for joining this live stream. And thank you if you are able to subscribe as well. That would be lovely. Thank you very much. Are calculations a necessary component of a database, i.e. save for uncertainty, propagation, or mean calculations? No, not necessarily. You don't have to have them. If you can, that would be great. But clearly, many database IAs are literally just going to be averaging and propagating the errors and plotting a graph. And we are keenly aware of that as moderators, and I'm aware of the database limitations from doing them, many of them myself. So enjoy, that's absolutely fine. Average where you can. If you can process it all, that's great, but don't worry about it. Averaging is okay just for database. You're very welcome, guys. Thank you very much for coming along. That was great, really good. If you could find any questions afterwards, just drop me an email at mrmforchem@gmail.com. Feel free to share this video with anybody you think it might be useful. And yeah, I would like to see you actually moderating an IA. Anupa, if you look on my channel, I have done a number of live streams with live moderation of internal assessments, both database, primary data, and I even have a playlist on computational IA, which is growing traction at the moment. So please have a look on my channel in internal assessment playlist, Anupa, and you'll see live moderation. The IAs are actually linked underneath the video. You can have a look at them yourself and have a go at marking them and see how you did against what the students got. Anupa, this is also linked on In Thinking by Jeff News, who's also used my videos for a number of posts. If you look at the internal assessment section on In Thinking, then you will find my video and the IAs to mark as part of Jeff News's site as well. Awesome, guys. Right, well, thank you very much for joining. We'll sign off now, 5 minutes early. And yeah, WebMO, yes, all over it, Amal. Love it. Absolutely love it. My favourite thing at the moment. Agreed, Amal. Agreed. Great resource. And links to all the databases as well, so you can quickly get the NMR and the IR and all that stuff. And it's just so open-ended. John Chu introduced me, and I'm very indebted for him for that. Right, guys, best of luck this season. Keep doing what you're doing. Clearly you care a lot about your kids. And kids, keep going. You'll get there. All right? Good luck, guys. Thank you for watching.